On to chapter 10, function operations. So we're going to look at sums and differences first. We will also be doing some multiplication and division as well. So you can form new functions by performing operations with functions. So just like if we were multiplying 3 times 5 or 2 plus 5, we can actually combine them by putting an addition sign. Now there's two ways this can look. So here we have h of x is equal to f of x plus g of x. This way probably makes the most sense to you. Or I can say h of x equals to, in brackets first, f plus g. And the diploma does like to write it that way. Okay? And so for difference or subtraction, you're going to see the same thing. We can actually write it as the subtraction of the two functions, but we can also write it this way where it's f minus g in brackets first, then the x. And again, this way probably makes more sense to most people, but typically the diploma will write it the second way here. So we're going to do some adding right away. So we have these two functions, f of x and g of x. So we want to determine the equation of h of x, which is f plus g of x. All right, so we're going to take our two equations and add them then. So we'll find that h of x is equal to negative 4x minus 3 plus, I don't need brackets here because it's an addition. Be more careful if it's subtraction. So therefore I find out that h of x was equal to 2x squared minus 4x minus 3. Now I just put this in the proper order so that it's a little bit easier when we have to graph this, because that's part A done. Part B, a little bit tougher. Well, I say tougher, but I mean just longer. So it wants us to sketch all three graphs on the same coordinate axis, and then we're going to look at some things based on that. We'll start with h of x then, and I'm going to complete the square first so that I can graph this a little bit easier. So I will factor out that 2, and so I'm left with x squared minus 2x and minus 3. Then we're going to divide this by 2, so we get negative 1, and then we'll square it, so we get 1. Now we can't just add 1, so we have to also subtract that 1, but there is a 2. This is actually 2 times 1. So then we get h of x is equal to, well, this is now a perfect square, so you get x minus 1, because this is a negative 2x here. So we get x minus 1 squared, and then we get minus 5. So now I can start graphing that. I'll do that in blue. So here we know that we have a vertex of 1 comma negative 5. So 1 comma negative 5 is right here, so we'll label that point. Some other things that we can find out based on this is that well, even before we did this, we see that we have a 3 here, so then we know that our y-intercept is negative 3. So that's going to be 0 comma negative 3. Now due to symmetry, that means that 1 over and 2 up, so then we're going to go 1 over 2 up, so we should have another point here. And the last thing is we should do an x-intercept. So we're going to let, I'll say that's x-intercept. We'll let h of x equals 0. Oops, sorry, that's a 1. So we'll add 5 to both sides. Then we'll divide by 2. And now we need to square root both sides. So we're going to get plus or minus the square root of 5 over 2. And we still have x minus 1. And then I'm going to add 1 to both sides. Now I'm just going to put what both these answers are, because it's not going to be an exact value here. So 2.58 and negative 0.58. So those are my x-intercepts. So I can go and graph those. 2.58 is around here. So that's going to be 2.58 comma 0. And then negative 0.58 is around here. So we get negative 0.58 comma 0. Okay, so that should be enough that I can actually sketch what this graph looks like. Make sure you got arrows showing that it keeps on going forever. Okay, we've got h of x done. Let's do f of x. it's linear, it's a little bit easier. So we've got -3 as our intercept, or y-intercept, and then we have a slope of -4. So I will go down 4, so 1, 2, 3, 4 over 1, down 4, 1, 2, 3, 4 over 1. And then I'll just reverse. I can't use a ruler, so 1, 2, 3, 4. And then over 1, 1, 2, 3, 4. Okay. Now you should use a ruler here. So we've got something that looks a little like that. And I'm going to label that g of x. And we should label our blue graph h of x. So just one left over. And that is going to be g of x. Now g of x is a little bit easier parabola. So its vertex is at 0, 0, or at the origin. And I'm just going to find a point. So for g of x, I'm going to do g of 1. So then we get 2 times 1 squared, which is just 2. So then I have the point 1, 2. And due to symmetry then, at -1 it'll also be 2. And so we can start. There we go. We can kind of finish that. Perfect. So we've sketched the graphs. Now why is that important? Well, when we're adding, we're literally adding the heights. So if I look at the y-intercept, that might be the easiest place here. My green graph was at -3. The red graph was at 0. So -3 plus 0 is -3. So that's why h of x is at -3. And if we kind of look here at 1, I think we have points all along 1 as well. So the red graph was at 2. The green graph was at -7. So -7 plus 2 is -5. And hey, that's where our h of x is. Now, because these are both parabolas and we're not labeling every point, it's not always as easy just to look at the points, but there will be some questions where all the points will be given, and all you have to do is add them. Now, the last part is state the domain and range. So I'm going to do that in the top right. So we'll do C for h of x. So h of x has a domain of, well, it actually looks like there can be any x value. So x such that x is a real number. And then our range, well, we can go all the way to bigger than -5, so y such that y is greater than or equal to -5, but it still is a real number. Now to find the range, you generally have to graph the equation or function. To find the domain, though, it's based off of our other two equations that we're adding. So here, because they both had a domain of real numbers, h of x is also going to have a domain of real numbers.